Order fulfillment. Order fulfillment in British English. Order fulfillment is in the most general sense the complete process from point of sales inquiry to delivery of a product to the customer. Sometimes order fulfillment is used to describe the more narrow act of distribution or the logistics function. However, in the broader sense it refers to the way firms respond to customer orders. Classification. The first research towards defining order fulfillment strategies was published by Hans Workman and was continued by Hal Mather in his discussion of the P/D ratio, whereby P is defined as the production lead time, i.e. how long it takes to manufacture a product, and D is the demand lead time. D can be viewed as the lead time quoted by the firm to the customer, the lead time the customer wishes it was, the competitive lead time based on comparing P and D. A firm has several basic strategic order fulfillment options. Engineer to order ETO/DP here. The product is designed and built to customer specifications. This approach is most common for large construction projects and one-off products, such as Formula One cars. Build to order BTO, SIN, make to order MTO/DP here. The product is based on a standard design, but component production and manufacture of the final product is linked to the order placed by the final customer's specifications. This strategy is typical for high-end motor vehicles and aircraft. Assemble to order ATO, SIN, assemble to request DP here. The product is built to customer specifications from a stock of existing components. This assumes a modular product architecture that allows for the final product. Make to stock MTS, SIN, build to forecast BTFD equals 0 here. The product is built against a sales forecast and sold to the customer from finished goods stock. This approach is common in the grocery and retail sectors. Digital copy DCD equals 0, P equals 0, where products are digital assets and inventory is maintained with a single digital master. Copies are created on demand, downloaded and saved on customers' storage devices, such as research papers. Processes. In the broader sense, the possible processes in a logistic production system are product inquiry, initial inquiry about offerings, visit to the website, catalog requests, sales quote, budgetary or availability quote, order configuration, where ordered items need selection of options or order lines need to be compatible with each other, order booking, the formal order, placement or closing of the deal, issuing by the customer of a purchase order, order acknowledgement / confirmation that the order is booked and / or received, invoicing / billing, the presentment of the commercial invoice / bill to the customer, order sourcing / planning, determining the source / location of items to be shipped, order changes to orders if needed, order processing process step, where the distribution center or warehouse is responsible to fill, order, receive and stock inventory, pick, pack and ship orders. Shipment, the shipment and transportation of the goods. Track and trace, determine the current and past locations of the goods during transit. Delivery, the delivery of the goods to the consignee / customer. Settlement, the payment of the charges for goods / services / delivery. Returns, in case the goods are unacceptable / are not required. Strategic importance. The order fulfillment strategy also determines the decoupling point in the supply chain, which describes the point in the system where the push or forecast-driven and pull or demand-driven demand chain management elements of the supply chain meet. The decoupling point always is an inventory buffer that is needed to cater for the discrepancy between the sales forecast and the actual demand, i.e., the forecast error. Typically, the higher the P/D ratio, the more the firm relies on forecasts and inventories. Hal Mather suggests 3 ways to tackle this planning dilemma. Improve forecasting accuracy, provide for flexibility, build a process to recognize forecasting errors and quickly correct production planning. It has become increasingly necessary to move the decoupling point in the supply chain to minimize the dependence on forecast and to maximize the REAC. This initiative in the distribution elements of the supply chain corresponds to the just-in-time initiatives pioneered by Toyota. The order fulfillment strategy has also strong implications on how firms customize their products and deal with product variety. Strategies that can be used to mitigate the impact of product variety include modularity, option bundling, late configuration, and build-to-order BTO strategies, all of which are generally referred as mass customization strategies. The decoupling point can place a much stronger emphasis on supply chain based on the process as well as nature of supply chain configurations. References equals